multiplying of polynomials. And the nice thing about multiplying polynomials, ladies and gentlemen, is you actually already know half of this lesson because we taught you how to distribute. Okay, we've been distributing since the beginning of the year, and you guys are distributing back in middle school, which is why we start with it. But now what we're going to have to do is combine what we know about multiplying with distribution and use our exponents with chapter 8, which is why we had to get through that before we could get in here to chapter 10. And so if it's simply a monomial, one term, notice it's not one number, it's one term. The 3 and the x squared stay together as a term. You're going to distribute it to every term in the rest of the polynomial. So ladies and gentlemen, multiplication doesn't rely on any like terms. All right, I don't have to match things up. Whatever I give you, you get to multiply. No matter how ugly it looks or how different they look, you get to multiply them together. So we do 3x squared times 5x to the third. For some of you, this could have been our quiz question on chapter 8. Because we're going to do 3 times 5 is 15. And what are we going to do with those exponents? Add them together, x to the 5th. So those of you who are still a little shaky in chapter 8, the nice thing about chapter 10 here is we're going to review a lot of those rules before we go into the marking period exam, okay guys? We're then going to go through and distribute. Again, you have to go to all of them. This should be a negative 6x to the 4th. And I know, guys, it may be a little small in here, but you need to be looking at my board to get the answer correct. No, you should be able to read it in your paper and answer my question. 3x squared times 4x is 12x to the third. Why third?
Oh,
Jesse?
because it's just x to the first power.
Good job. This is 1x here, x to the first power. So 2 plus 1 is 3. Now, what would have happened here, ladies and gentlemen, is if you had wrote this one as x squared, guess what your last term would have also been written as? X squared, because we're going to have 3x squared times a negative 8 is minus 8x squared. You're not going to have two of the same term in these monomial problems. Okay, guys? Also notice, did our answer stay in standard form? Does it still go from largest to smallest? 5, 4, 3, and 2. Negative 8, how about negative 24? Did I say negative 24, guys, and just wrote the 8 down? All right. Okay. I had negative 24 in my head. It never came out of my mouth. Sorry. All right. So any questions on distributing, guys? That should go pretty smoothly, correct? All right. Now what we're going to do is a binomial times a binomial, and we're going to use what's called FOIL. What I find is I don't use that word very often anymore. I basically just say to distribute. But what FOIL stands for is first. So we're going to take the first term of this binomial times the first term of the second binomial. So F stands for first. This is an F-I-R-S for first. So what's 6x times 2x? 12x squared. Good job. I was waiting to hear x squared there. I need to then use O. O stands for the outside. So that means you're going to take the outside term. Good job. 6x times 7. So if you notice, ladies and gentlemen, basically all I did was distribute 6x, correct? But I had to jump into the second term. I had to jump into the second set of parentheses, all right? So when you distribute, you have to get into that second parentheses. We don't do 6x times the 5 there. But this is a plus 42x. I, does anyone have any idea what I might stand for? Inside. O stands for outside. Did you guys do this last year in Mr. McGrain's class?
No.
Oh. Well, you don't get it. You're not going to count.
No, we did. Oil?
Well, now here's what you need. Like, if you had Mr. McGrain for Algebra 1 last year, then yes, you had to have done it. If you had it for just 8th grade math last year, then that's the class I'm asking about. We should have minus 10x. And then guess what L stands for? Last. So they're kind of opposites of each other, right? First and last, inside, outside. But once again, guys, notice I and L, isn't that just letting me distribute a negative 5? So if you're not someone who does well memorizing acronyms, memorizing cute little sayings, keep in mind, all this is a distribution problem, but I have to distribute twice. This gives me negative 35. So that was the first part. It said use the FOIL process, right? What's the second part tell you to do? Combine like terms. I still want my answer to be in standard form, so I'm going to keep this x squared as my first term. 99% of the time, ladies and gentlemen, that first term is going to be the first term in your multiplication is going to be the first term in your final answer. After x squared, you need to put your x's, so this should be plus 32x. And then what term have I used yet? The minus 35. Are we okay with that, ladies and gentlemen? All right. And last but not least, we give you this third example, guys, because you will see it. But a binomial times a trinomial is just that distribution. I'm going to take x times 3x squared, x times negative 4x, and x times 1. So I'm going to distribute this x to 3 terms. I'm going to get 3x to the third minus 4x squared plus x. So that was the first part of the distribution because x was the first term in my binomial. I now need to do a second distribution with what number? 5. And I need to distribute it 3 times. So I'm going to end up with 6 total terms this time instead of just 4. So I get 15x squared minus 20x
19
plus 5.
minus
Okay.
19.
Well, I haven't combined any of my like terms yet. I'm just doing the distribution. So tonight, ladies and gentlemen, I'm going to expect your problems to be written down and your multiplication to go out. Because adding, I'm usually pretty good at looking at your work to know where the mistake is at. The problem with multiplying, guys, is we're not only multiplying, what are we also doing here at the end? Adding. And so because there's those 2 steps, it makes it a little bit more difficult for me to know what your mistake is. So I need you guys to show your work. We are going to do the same thing, put it in standard form. We have 3x to the third, this negative 4x squared and 15x squared, what's that going to give me? What's negative 4x and or negative 4 plus 15? Is that a 9 or an 11? 11x squared. I then have positive 1x and negative 20x, and I think Andrew told us minus 19x, and then what's hanging out here at the end? Plus 5. Once again, ladies and gentlemen, 99% of the time, your first term is going to be your leading term. Your last term is going to be your constant in there at the end. All right? So, ladies and gentlemen, let's go through and do some examples here together. I want you guys to try 1, 2, 3 on your own. I know I called them examples, but I would like you guys to work on your own. And then we're going to call people up to the board to give us their work. So, I'll walk around and answer any questions. Make sure you put your plus in between there for those positives. But number 1, we distribute real quickly. Remember to add our exponents, and we're done. Number 2, we distribute. We add our exponents. Pay attention to all of your signs. And then we have to combine like terms. Now realize, ladies and gentlemen, you can't change your exponent here. Because if you changed your exponent here, you would then create x squared. And do we already have our x squared term? Yeah. So you can't create a new exponent in this combining step. And then John has x to the third plus 3x squared minus 19x plus 18. Beautiful. Ladies and gentlemen, we're going to take a look at some area formulas on the back side. So let's show you guys how you can use this, because you are going to be using it this way in your homework tonight. I have to fight over the saw. I don't want to fight over you guys. So you cannot talk. Plain and simple. Do you guys get that?
Yeah.
Okay, then if we understand, then let's start doing that. Ladies and gentlemen, I give you the formula for the area of a rectangle. Area equals length times width, and so you're going to use those dimensions. It doesn't matter which one you call length and width. I just need to multiply those 2 polynomials together. They're 2 binomials, so do they match one of our examples on the front side? Yes. So we're going to have x times 2x is 2x squared. X times negative 4 is negative 4x. Now, if you wrote your 2x minus 4 first, could your first line of work look a little bit different than mine? Be in a different order, but are we still going to have the exact same terms, ladies and gentlemen? Yeah. We then have to do 2 times 2x, which is 4x, and then 2 times negative 4 is negative 8. What am I going to do from there? I've already distributed. What do we do after distributing? Combine like terms. There's only one x squared, so it stays 2x squared. What's happening with my x's, ladies and gentlemen? They cancel. There's no x's. Don't call it 0 and then put an x in there. You cancel it out completely, and then we have minus 8. Ladies and gentlemen, you have to put area equals, and then you're going to have to look closely at the problems that you're given. These don't have any dimensions, so we call it units. I'm going to have to write that out. This units squared. All right? I'm going to start making sure I set you guys up with some good habits to go to geometry. But anytime we find area, we have to label that. All right? What's our next shape? A triangle. So let's go take a look at the triangle. Triangle is 1/2 length times width, or 1/2 base times height. Not base times width, base times height, guys. Whichever formula you're more familiar with. So if we take it what that looks like, we have 1/2, and then I'm going to do x squared plus 2 times x minus 3. Now, ladies and gentlemen, we could distribute that 1/2, correct? But then I'm going to have fractions in my problem from the rest of the way out, correct? So what I would suggest doing is this. You're going to multiply this together and then distribute your 1/2. Save that 1/2 for the end. Does that make sense, guys? But what you're going to have to remember is that 1/2 is going to need to be distributed to everything that we create in our answer from this binomial times a binomial. This becomes x to the third. This becomes minus 3x squared. This is going to give me plus 2x. And then we have minus 6. Now notice, ladies and gentlemen, we did a binomial times a binomial, but do I have any like terms to combine? No. So we're not always going to have the like terms to combine, but you at least need to look for that. So now what I'm going to do is I'm going to distribute the 1/2, but the 1/2 has to go to all 4 of those terms. Does that make sense, ladies and gentlemen?
How do you get x? X to the third, how do you get that?
It's just 1/2 x to the third. All you're doing is multiplying the coefficient, ladies and gentlemen. So what's 1/2 times 1? 1/2. So you're going to do x to the third and then take half of that. So whatever x to the third would be once we have values. This is minus 1.5 x squared, because 1/2 times 3 is 1.5. Could we call it 3/2 and have the same answer? Yeah. Plus x, because 2 times 1/2 is 1. And then minus 3. How am I getting that minus 3? Half of 6 is 3. Ladies and gentlemen, we're going to label this as A equals. And did they give me any dimensions here? No, they don't tell me whether this is centimeters or meters. So you're going to label it as units squared. Ladies and gentlemen, we're going to save the trapezoid for your warm-up on Monday. Okay? So we should be okay here. Your assignment, let's see, I don't know if I have it typed up here. I don't think I do. So your assignment, ladies and gentlemen, is on your note-taking guide. It is a book assignment again. 587, 18 through 46 evens, ladies and gentlemen. Write down problem, show work. Do we understand my expectations, ladies and gentlemen?
Yes.
All right, I'll freeze that, and you guys can get started. 15 problems, not too bad.